Hello and good morning. Let's start with another biweekly contest. So the first problem is creating grid with exactly one path. So you are given two integer n and m representing number of rows and column in a grid. Construct any m cross n grid consist of only character this and this. This represent a free cell and this represent a block cell. Okay. A valid path is a sequence of free cell that start from top left cell that is 0 comma 0 and end at bottom right cell that is n minus 1 and n minus 1. Okay, move only right, that is from I comma j to I j comma 1, that is we can move one column next, or down, that is I comma j to I plus 1 j, that is one row below. Okay, return any grid such that there is exactly one valid path from top left cell to the bottom right cell. Okay, let's see example. So there is n ms2 and s3, that are two rows and three columns, and we need to return a grid of size 2 comma 3 such that there is only one path from 0 comma 0 to 1 comma 2 that only use dots. So suppose that for this is a one valid copy to this. So okay, so this is one possible solution. So the path is going to be, we will start from here, then move to this cell, and then go to this cell, and then this cell. So this is only path in the grid, so that we can reach from this top cell to this final cell, and there is no other path such that using only dot we can reach to n minus 1 m minus 1. Okay, if we take this path, suppose we go to this, but this is blocked, so we can't move here. So from here we can only go to this, and from here if we try this, then this is also blocked, so we can't go, so we need to return to here. So this is the only path possible in this grid. Okay, now move to the next example. Okay, so it's 3 comma 3 grid. So in this case, one possible path is that from here we go to here, and from here we go to here, and from here we go to here, and from here we go to here. So this is the only possible path in the grid, and in this problem the grid which we need to return is should have only one path. So from here, if we go to there, this is blocked. If we, from here we go to this is blocked. From here we go this is blocked. So there is only one path, that is this. So we are given n and m, and we need to return one grid that have only one possible path, and we need to place this h and dot. Okay. So for this problem, what we can do is that if this is the grid, so what we're going to do is that best what we can do is this. Suppose we need to return answer for 2 comma 3. So what one of the possible answer can be, we place dot here and dot, also dot here and h here. Okay. So this is not dot. So one possible path will be, we go to here, we go to here, and go to here. So this is only one path. We will go straight and then down, and there will be no other part. So what we are going to do is that in first row we will place dot, and in last column in downward direction we are going to place dot. So there will be only one path that will go around this row and then down, and all other paths are already blocked, so we have no other path. Let's see with second test case. Copy image. So if we change that also, so this will become dot and this will convert to h. So the only possible path will remain is that we will move along this first row, then downward, then downward, and there is no other path we can reach from top most to down last, because all these cells are blocked. If we try to go here, this is going to block. So there is only one path. So the solution for this is this: for in we will create a vector of answer that we are going to return, move along a row, and for column, if it's first column, we need to just place dot around first row. So these are the n length dots only. Okay, and if there is any other row, we need to first in n minus 1 places we need to place this s, and at last this dot. So they are n minus 1 h and at last dot, and now at last we just need to push that st and return this answer. So this is the one of the possible grid, valid grid, and there may be another possible grid, but this is one of the possible grid, and we need to return any one possible grid. So this is the solution for first problem. Now move to the next problem. So problem name is minimum light to illustrate a road. So you are given an integer array lights of length n, representing position 0 to n minus 1 on road. Okay. So for each position, if light I equal to V, where V is greater than 0, there is a working bulb at position I. Okay. That illustrate every position from max of 0 I minus 1 to min of n minus 1 I plus 1. Okay. So there is some integer index 0 to n minus 1. Okay. And each index there is some light placed whose value is going to be V. And if this value is greater than 0, this bulb is going to illustrate at some places, and the places is it going to cover some range where light going to illustrate. So this range is max of 0 to I minus. So V point previous and V point next, all those points going to be illustrated if there is a light at index I with value V. If at an index light I is 0, there is no working bulb at position I. If they at an index light of I is 0, then there is no bulb. So this if there is no bulb at this position, it is not illustrating any position. So we are given array, and array there are values of light placed at that place, and the value is representing the range in which it is illustrating illustration. So a position is visible if it is illustrated by at least one working bulb. Okay. You may install additional bulb at any position, and each additional bulb installed at position j illustrate from 0 to 0 j minus 1 to min of n minus 1 j plus 1. So at any position we can place a bulb, and that bulb is going to illustrate one position previous and one position next. So it's going to have three range values. Okay, so we need to return minimum number of additional verbs required to make every position on the road visible. Okay, let's take first example. So, so initially there is no bulb, so every value is 0. So we need to place bulb. So what can do? We place bulb at first position. So if we place bulb at first position, it is going to illustrate the second position also. But next position, so this can only cover one next and one previous. So only next position can be covered. As next value is also 0, we need to place bulb, and this is going to also cover next position. So minimum bulb that will be required as 2. So this is the one of the possible case. Okay, another possibility that we will not place bulb at, but we will place it at bulb at second position. But placing this bulb at second position will also illustrate first position and next position. So there is no need to place bulb at one next and one previous. Now we are remaining with just one position, that is last one, and we need to place the bulb. So these are the two possible places where you can place bulb, and this is going to cover all range. So minimum answer for this is going to be 2. Now next, see the next test case. So, okay. Okay, so this value is 2. So it's going to illustrate to current position and to previous. Because its value is 2, it's going to cover 2 position previous and 2 position next. So next is this. And there is no index next to it. So it cannot cross this. So we are remaining with just this position that we want to eliminate. So one of the possible that we place bulb at this position, it's going to cover that. So we will place one bulb here. So for this answer is going to be 1. There's next one. Okay, so done. So think what we need to observe is that when so first is that first we need to find the all the position which are we are able to illustrate with the current values. So if there is an existing light, so it is going to cover some places. So we just first we calculate all find out all the position which are already illuminated. There is no need to calculate answer for them. Second point that need to be observed that if we are placing bulb at any position, it's going to cover a range of 3 position. So the best is that we place bulb if there is a range of some places that is not illuminated, we will place bulb at middle so that it cover 3 range value. I hope this makes you clear. Now move to the code part. So first we create length, the length of array. Next we calculate, create a vector of size n. So this is going to store the bulb which are illuminate, how many light are illuminating any index I. So for this what we are going to do is that we are using prefix sum. So what for while we just travel across the array and if value is greater than 0 we increase the value of index L v value previous, and if next we are just going to subtract this. So I hope this makes you clear how we are doing. I will cover this part in another video because it's standard. So if we want to store this part that how many values are covered with this range, this can be solved with a prefix sum value increment. So let's cover that. Okay, so mm, so take this example here. So what I am doing is if value is 2 at we will go here increase this by 2 and at this point we will going to subtract this by 2. So after this I am doing this prefix sum. So this value is going to be 0 and this value is going to be 2. 2 we are increasing by 1. Okay, increasing by 1. Sorry. So this is going to be 1. This is going to be 1 and this is going to be minus 1. So when we are going to calculate prefix sum, this is going to be 0, this is going to be 1, and 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 then here it will become 0. So with this value we have increment 2 position this before and decrement 2 plus 1 with 1. So this will also remain 1. So suppose let's make it better. Insert table, insert column left, insert column right, table, insert column right, insert column right. So if suppose that the here value is 0 and here 0, so okay, so we'll two previous value we increment this 1 and 1 plus, so here we will decrement by 1. So these range are going to be covered by this 2 value. Okay, so when we are going to calculate prefix sum, so this value is going to be 0, this is going to be 1, this is going to be 1, this because we are going to add this value to next position and these value are initially 0. Okay, so this is again going to be 1, this is going to be 1, this is going to be 1, and this will become 0 again because of adding this minus 1. Initially that a array is going to be have value as 0. Okay, so these are representing how many lights are illuminating any index. So if there is any other value, suppose that if here is going to be 1, then this is going to increment here by 1. Okay, and 1 plus 2, here we will decrease it by 1 also. So then this value is going to 2, and then this 2, and this 2, and this 2, and this will again become 0. So these values are representing how many bulb are illuminating at an index. Okay, now move to the code part. So first part, we increment the index before 1, and if there is the next index v plus 1 index, we are decreasing by 1, and next we are calculating this prefix of I. So this a is storing the number of bulb, and the index, how many bulb are illuminating at an index. Okay, now move to the next part. We have an answer and g equals 0. So while moving across A, if value is greater than 0, that is there are some bulb illuminating an index, we will just increment by and move to next index. Okay, if there is some index that is not illuminated by any index, we are going to place bulb one next to it. Why? Because every bulb is covering 3 position, so there is no point that we place bulb at initial position. It's better to place one next to it so that it cover current index. If in case there is no bulb at next index, it is going to solve problem for that also, and also for one index next to it. So at this place we are incrementing index by 3 and placing bulb next to the current position. So this is the greedy approach we are doing. So when we are going to place answer, we just increment this and with this return the answer. I hope this makes you clear. If you have any doubt, let me know. Now move to the next part. Okay, so problem name is finish time of a task 1. So you are given integer n representing number of tasks in a project, numbered from 0 to n minus 1. These tasks are connected as a tree rooted at task 0. This represented by 2D integer array edges of length n minus 1, where edge AI indicate that there is a task UI and parent of task VI. So, okay, parent is VI. Okay, okay, okay. So we are given a tree and with edges U and VI. Apart from this, we are given an array. You are also given an array base time of length, and where baseline is the parent time to complete task I. Okay, so there is a tree with index 0 to n minus 1, where whose edges are again as UV, and there is an array of base time with whose I represent task to complete any node. Okay, finish time of each task is calculated as follow. Leaf node, the finish time is base time. So for leaf node, the array index corresponding to its going to be completing time of that task. For non-leaf node, let earliest time be maximum finish time among its children, minimum finish time of among its children, and latest be the maximum finish time among its children. Okay, let down duration be latest minus earliest plus base time of I. Okay, so if for non-leaf loop there are some children, we need to take out minimum and maximum. Minimum going to be earliest and maximum going to be latest among all its children. So, and next we can need to calculate on duration. It's going to be latest minus earliest plus base time. Base time is the for current index. So the difference between maximum minimum plus value of current index. And for this node, the finish time is latest plus duration. Latest is maximum. So maximum plus this duration. And we need to find finish time of the root 0. So this is the completely implementation based problem. So let's take this example. Copy, just copy image, copy image. Okay, okay. So now take out this array also. Paste. Okay. So for 0, we need to return the time to complete the task. Okay. So now start from the root node. Root node is 3. For 3, the answer is going to be the whatever base time is, that is 3. Okay. Now calculate answer for node 1. That is, so for node 1, we need to find maximum minimum among us children, and then we need to calculate duration and then time 2. Okay, so for 1 there is only one children, that is 2, and there whose answer is only 3. So max is going to be 3 and min is going to be 3, and then duration is going to be max minus 1, that is 3 minus 3, plus base time, that is corresponding answer is for this index the value is 5, so it's going to be 5, and for this time going to be duration plus maximum, that is 3, that is going to be 8. So for 3 the duration is 8. Now we need to calculate answer for 0. For 0 we need to find max, that is there is only one children, that is 1, and for that answer is 8. So max and min is going to be 8, and duration is going to be 8 minus 8 plus value of this current, that is 9. It's going to be 9, and for this time is going to be 9 plus maximum, that is 8, and it's going to be 70. So for this it's 70. Now next move to the second part. So in this case, okay, now start from the root nodes. Let's start with the index 2. So this is root node, so for this answer is going to be 6. Now move to the next node, root node, that is 1. For this also answer is going to be 7. And now move to the 0 node. So we need to find max and min among its children. So there are two children, that is 1 and 2. And for those answer we need to take, for those node we need to take maximum of the and minimum of those answers. So maximum is going to be 7, that is node 1, and minimum going to be 6. Now we need to calculate duration, that is 7 minus 6. 7 minus 6 plus answer for this node, that is 4. It's going to be 5. Now we need to calculate duration. Duration is going to be 5 plus maximum, that is 7. It's going to be 12, if I'm not wrong. 12. Yes. Now move to the next part. Okay. We need to cover this also. Let's cover. So there is 0 and 1, 0 to 2, 2 to 3. Okay. This is the case. What are values? 5, 4, 8. Now calculate answer for 3. Starts. We are going to start from root node, because for calculating root we need answer for it. Non-root we need answer for its children. So we are going to start from root. So for 3 answer is going to be 0, 1, 2, 3. That is 1. For 1 the answer is going to be 5. 5, 8. These are the root nodes. So for this and this. Now move to the next node, that is 2, for whose answer of all children is calculated. So we are calculating answer 2 because all its children are already calculated, that is 3. For 3 max is going to be 1 and min is going to be 1, because these are values for 3, and duration going to be 1 minus 1 plus value for this index, that is for 2, 0, 1, 2 is 2. So for this is going to 2, and duration is going to be 2 plus max, that is 1, that is 3. Okay. So for index 2 the value is going to be 3. Now calculate the answer for 0. 0 there are two children, that is 1 and 2, and we need to calculate maximum and minimum for those. So maximum is for one answer is 8, and minimum for answer 2 the answer is 3, if I'm not wrong. Let me check. For 2 answers, okay, going correct. Okay, now going to duration is going to be 8 minus 3, that is 5, plus value for index 0, that is 5. That's going to be 10. Yes, it's correct. Now in duration is going to 10 plus value of maximum, that is 18. So it's going to be 18. That is correct. 18. Okay. Yes. So this is a directly a implementation this problem. So we will go in DFS order, reach child node, calculate answer for those child node, because those going to be directly the answer for those index value. Next we as in DFS we have, as we are moving in DFS we have when we reach any node, we have already calculated answer for all the children. While we just maintain two index values, that is min and max, and this min max for parent across all children. At last we just calculate this duration and this values. So this is directly an implementation problem. So first I create this graph from those edges. So this is the graph. Next, directly call those DFS with by passing start node and its parent. Because it's a tree, we are just storing current node and parents in order to avoid back edges. Next, we are returning this graph and this BT, that is values of those index. Now in DFS, if it's child node, this is the case if there is only one node. So this is special case. If there is one node, we are going to return the value of the current node. If it's if it's a child node, so if it's child node, there is going to be one value, and that is pointing to its parent. So we're going to return that value. Next, we are going to maintain two values, that is min max. So while moving DFS, we are updating this min max of around its children. So if now we have min max, calculate duration with min minus max plus value of current index, and then duration plus maximum value of among its children. So this is the solution around DFS. So it's directly an implementation whatever problem is asking. Now move to the next question, that is count good integer in a range. Okay. So you are given three integer L, R and K. Okay. Number is considered good if absolute difference between every pair of adjacent digits is at most k. Okay. Return number of good integer in range L to R inclusive. Absolute difference between two integers defined as ABS. So there is a range L to R given and integer k, and along this range L to R, we need to find how many integer lying in this range whose different. So if there is index x that is in between L and R, so whatever digit in this XR, so corresponding absolute difference between every so adjacent pair in digit x going to be lesser than equal to k. So suppose take an example, there is 10 and 15. So we need to find all count of all the integer in between 10 to 15 whose difference between adjacent digits is lesser than equal to 1. So one possible is 10. So 10, there is one only one adjacent digit, that 1 and 0, and its absolute difference is 1, that is lesser than equal to k. Next possible is 11. Okay, for 11 the absolute difference is 1 minus 1 when 0, that is lesser than or equal to k. Next possible is 12. So 12 is in between 10 and 15, and absolute difference 1 minus 2, and that is 1 lesser than. If we consider 13, so 13 the absolute difference is going to be 1 minus 3, that is 2, and 2 is going to be greater than k. So we are not considering that integer. Next, if we consider 14, that is in between, but the difference is going to be 1 minus 4, that is 3, that is greater than 3. So we are not considering this. Next possible, this is 15. So the 15, 1 minus 4, that is 4, that is greater than k. We are not considering that. So the for this answer is going to be 3. Okay. Next range is given this 201 to 204 in case 2. So for 201, so 201 there are two possible indexes, that is 2 and 0 and then 0 and 1. So we need to check both those part whether they are lesser than equal to k. So first we check 2 minus 0, that is 2 lesser than equal to k, and 0 minus 1, that is first we need to see this part and then 0 and 1. So 0 and 1. Okay, so both are lesser than equal to k, so this is going to consider. Next is 202, and so for 20 first we will see 2 and 0 and then 0 and 2, and both are lesser than equal to 2, so this is going to be considered for the answer. Next possible is 203. So 203. So for 20 we need to consider 20. For 20 it's going to be ABS of 2 minus 0, it is going to be 2, that is less than equal to 2. Next it's going to be 0 and 3. ABS of 0 minus 3 is going to be 3, that is not greater than 2. So for this 203 is not considered. Next is 204. 204, 20, the ABS is 2 minus 0. 2 minus 0, that is 2 lesser than equal to 2. And next is 0 and 4. ABS is going to be 0 minus 4, that is 4, that is greater than 2, so not considered. So in L2R range, we need to find how many x are there, so that that digit present in x, the adjacent position absolute difference should be lesser than equal to k. So this is the standard problem. You can consider it a digit TP standard problem. So I may consider I will cover that in any digit playlist. So let's move to the code part. So in DJB, we standardly we create these two strings that are representing those range. So if first L is having digit lesser than R, we just insert 0 at the beginning, and next we just initialize this TP and call the TP part. Okay. Some changes I have done in standard TP that are not covered in this is that, so maximum digit going to be 15. At max I have taken 15, but this can be solved with 15 also. Okay. Next we have storing is that, so DP first is the place where we place digit placed. Okay, so first is digit at I. Okay. Next is the 11 is representing the previous value. So previously what we have placed, because if an index if any index we are placing any digit, we also need the whatever we have placed previously, because for those the difference should be lesser than equal to k. So if any index I am trying anything to place, we need to find whatever we have placed previously. I need to check whether they are lesser than equal to k before placing anything at index I. Next we are storing uh, a boolean value that is representing whether we have start placing at an index previous to it or not. So this too is a bool which representing whether so DP is going to calculate from beginning. So if we start placing digit or not. So why we are storing this? Suppose we are calculating answer 1 to 12. So uh, so we will insert 0 at beginning, because in order to make both string equal, and suppose we calculate 6, so this is going to be 0. So this 0 need to be maintained because we have placed 6. So for this index going, so this checking of previous, this check should not start computing, because in previous value we will store this key. In this index we are going to store the previous value, and till we have not started, there is no point to check that part, that previous value and current value lesser than equal to 6. So this bool is storing, so in order to avoid the previous value check till we start uh, creating the number. So I hope this makes you clear. Okay, now these are two indexes that can be maybe covered in the DDTP playlist. These are just to maintain the range which are possible to place at current index I. Okay, now move to the code part. So if we reach at the last index, there is nothing need to place. So we return 1 because we have created all possible cases. Next, if DP is already going to return it. So last two indexes, that is T1, T2, we have already said that these are used to find the possible value which we can place an index I. Okay. So possible values, I'm not considering that the previous value should be lesser than equal to k, and whether we have start placing or not. These are the standard thing whatever we can place at index I. So these check are the problem check, that is value lesser than equal to k, are going to covered in loop. So we try all possible integer that we can place at any index I. If t0, that is this is case that we have not start placing any digit at previous index, so this second check can be avoided. So if this is the case, there is nothing need to be checked second part. We are just going to call next TP state. that is L plus 1 and I. So this check is that we start placing or not. So the second part is that checking whether I have placed a non-zero digit. So if we have placed non-zero digit, we start placing, creating the digit. Next, these two index are standard in order to compute the possible ranges, and these are the low high strings and k value. Second check is that if we previously start placing number, then the difference of previous and current should be less than or equal to. Then only we can pass. So this is the part, and at last just store this answer. That's it. Okay. I hope this makes you clear. Apart from this, if you need any explanation for the this prefix sum, maybe I will cover some in other video, the prefix concept. This is a standard part. Apart from this, digit TP is also standard, so maybe covered in some another video. That's it. I hope this makes you clear. Thank you and bye.